Alright, so who all we have? We have Chris, Heer, Savya, Dave, Vaibhav, Heer, and Srivatsav. We'll probably give 2 more minutes before we start. Hey, Pranay. Alright. Hey, Neil. Hey, Anjika.
Hi.
Hi.
Hello, beta. What am I looking for? Yeah, this is better. So, did you guys get a chance to see the video of the previous class? Not primarily for seeing the quality. I mean, not for the content, but for the quality part of it. Earlier, what used to happen was I used to place the iPad in a position where it'll go in the reverse direction. So I had just placed the camera in a way that at least when you see the video, you'll be able to make out in a more convenient way. Alright, so let's do a quick roll call and then we'll get started. So we have Anjika, Dev, Heer, Chris, Neil, Savya, Sivatsav and Vaibhav. Aryan will not be able to join today. Here comes Ritika. Let me just send a reminder to everybody. The nursery will be late by a few minutes. Here comes Ananya. Okay, so let me just drop a note saying we are starting the class. We have started the class already. So basically, what we are going to cover today is going to be a continuation of what we were doing yesterday. So we looked at circle equation, standard form, and then we'll talk about certain features. How do you interpret circle equation? How do you deal with a non-standard form of a circle equation and then converting that into a standard circle form. Standard equation form for circle. Okay, so let's get started. Any question that you guys have with whatever we learned yesterday before I start? Can I assume that whatever we learned yesterday was somewhat understandable? Silence means yes. Okay. All right. So what we looked at yesterday was a standard form of a circle equation comes as x minus h square plus y minus k square equals r square, where h and k are, basically h and k are the coordinates of the center and r is the radius of the circle. Okay, so whatever we are going to do today, that is going to be 2 things. One is circle standard form, standard circle equation or standard form of the circle equation, and little bit of quadratic equation that you would have dealt with in the past. So let's deal with something interesting. So if I say I have an equation called an equation as x square plus 4x plus y square plus 6x plus, let's say, plus let's see, 13 equals equals 23. Okay, so I have put an equation right now. Just read the equation, and if I say we have to convert this into a standard circle equation. So two-step process. First is convert this into a standard circle equation and find out the coordinates of the center and the radius of the circle. So let me do one problem, and then I'll make you guys practice a little bit more. So I have x square, I have y square part, okay, and I have some constants. What we are trying to convert this into x minus h plus y minus k squared equals radius squared. So we have to see if we can convert this into this equation into this form. Now when you have an equation like this, you have to always look at how do you break it down. You start isolating things which are relatable. Meaning, let's say x squared and 4x. I can add or subtract something to this to make it like x plus something squared. So let's take this x squared plus 4x plus 4. If I keep it here, this becomes x plus 2 whole square. Okay. So I have gotten 4. Maybe I have borrowed 4 from here. Okay. Plus y squared plus 6y. If I put this, then this is y plus 3 whole square. Yeah. It's y squared plus 2 into y into 3, 6y plus 3 squared, that is 9. Okay. So this is x plus 2 whole square, and this is y plus 3 whole square. But we have 4 plus 9, 13. Here we had only 11. That means we borrowed 2 more. Okay. So we had only 11. Now we can say this equals 23. Is that part okay? So what I did was, I converted this part, I borrowed this part and added something to it to make it x plus 2 whole square. I took this part and I just added whatever I needed to convert this into y plus 3 whole square. And then that would have needed 4 plus 9, 13, but we had only 11. So that means we borrowed 2 extra. Now, if you look at this became x plus 2 whole square plus y plus 3 whole square minus 2 equals 23. Now if I keep everything, just the number on the other side, equals 25, which is nothing but, this goes this side and becomes plus, so this is 25, which is nothing but 5 square. So this equation that we had, that converted into standard circle equation form. From that, once you convert it to this form, then you know what is your coordinate of the center. So it is minus 2 comma minus 3. This is your coordinate of the center, and then this is the radius. So basically the type of question that you will end up dealing with when it comes to circle equation, you will need to know what is the circle equation, and then any equation that you are given, you'll have to convert that or transform that into a circle equation form. Okay, what am I calling it? Standard, let me read the actual term that is applicable for this one. It's called standard circle equation. Okay. So now let's but before I say now, is this part, are you guys able to relate to what I was saying? Was it understandable or it was confusing? Like always. Understandable? Okay. So let me give you guys a chance to get your hands dirty, because that's the only way we learn math. So let's say if I have an equation like x squared plus (14x) plus y squared plus 8y minus yeah. Can you guys convert this into a standard circle equation and tell me what is the center of the coordinates of the center and what is the radius of the circle? And I framed this question on the fly, so if the question turns out to be wrong, we'll see. So again, a quick summary of what we've done. We know that, okay, my circle equation is, if you memorize this as h, let's call it h equals r squared. This is the standard circle equation. What we have is a different quantity equation where we have x squared and y squared both. So what we are trying to do here is convert this into a standard circle equation, find out the coordinates of the center and the radius of the circle. Hey Dave.
Wait, so do you want the approach for this or the answer?
Both.
Okay.
You got the answer already?
No, I had the approach. I was going to do the answer.
Okay. So keep the approach with you for now. I want everybody to try.
Okay.
If you got the answer, you can just tell the answer. Approach part, I will come back to you guys. Okay. I will ask you guys to explain that. Yeah, Chris, you got the answer already?
Oh, yeah, sure, I have the answer.
Okay, what is the answer?
I got the center as 7, -4, and the radius as 13.
Radius is 13, okay. I'll take that as an answer. Ritika?
I got the same thing, sir.
Same. Okay. I will let you guys explain the approach. Let's give 5 more minutes to everybody else.
Sir, I got the same answer.
Same answer. Unfortunate, but true. Okay, let's see. So I was kind of tempted to teach something new, but then I thought we will cover up this one and then we will do a little bit of playing around with quadratic equations, because that's going to stay with us for a much longer time, and that's the backbone of everything that you will do with SETI. So we'll look at solving some of the quadratic equations also in different ways and see what all you guys remember, what you have forgotten, what you want to practice and things like that. So we'll come back to the solving quadratic equation also, and then if possible we'll probably look at some of the interesting properties of polynomials. Let's see how much we can do today. Is everybody able to progress and try something? Here, Neil, Sarah, Ananya. Yeah, I mean, I would recommend everybody to try, no matter whether we get the same answer or not. Okay, because trying is the key. you got it. Radius you got. What is 2?
Oh, -2, so this would be 65.
So how much is your radius? 169?
Ah.
What's it like? No. It is radius square.
Oh,
Yeah. Alright. So, do you want the DJ to get his hands dirty as well? Okay, before I do so, Chris or Dave, okay, Dave was the first one to raise hand today. So Dave, you want to explain what did you do? Just the approach part.
Okay, for the approach part, I see we have a negative 14x. So first I expanded that. So I did x squared. I did x minus 7x
Okay.
plus 49.
Okay. Okay.
And then for the y part, I did y minus 4y is equal to 16. So we could just rewrite that as y plus 4, like y squared plus 4 for the terminal equation. And then I just added 49 and 16.
Yeah, that gave you 65. But
Yeah.
what you had was 63, so you have to subtract 2.
Yeah,
And that gave you 167.
yeah.
Okay, so this became x minus 7 square plus y plus 4 square equals minus 2 equals 167. So x minus 7 square plus y plus 4 square equals 167 plus 2, 169, which is nothing but 13 square. Yep. And that is how you guys got the radius as 13. So this fits in this equation, right? So this is 13 square, so r is 13, and then your y coordinate is minus 4 and x coordinate is 7. Yeah. Alright. Now, did everybody understand what Dave explained and what I did, just hearing him out? Sarah, Neil, Nanya, Shravya, Peer, everybody?
Kind of.
Yeah, Nanya? You were able to follow what I did, right? It was easy to understand, right? No?
Yeah.
No. So don't be shy. If I have to explain one more time, I can do that. Shall I?
Yeah, a little. I get it, but
Okay.
it's and towards the end, it kind of gets confusing.
No, that's what I was doing purposefully, right? Sometimes when I'm asking you guys to explain, I say that, okay, assume your teacher is a 5th grader. But when I'm trying to explain, I assume everybody is super smart. So let me go slow. And anything that we do, right, it becomes much easier to comprehend if it is done in a simpler, easier way. So let me try doing that in a much simpler way. Okay? And there's no harm in doing things again, because that also ascertains that we don't leave any space for assumptions. So this was the equation. Y x square minus 14x, y square plus 8y plus 63. So by looking at this equation, right, what you see is, okay, I have x square minus 14x, okay, something that I can play with. I have y square plus 8y, that I can play with, because our ultimate goal is to convert this into x minus h square plus y minus k square equals r square. If I am able to convert two squares and equals something else square, that gives me the desired outcome for us. So here, this part I can play with.
Right, so,
Yeah.
sorry, the formula, so is is that like an equation you have to make into this formula?
Yes, so this is the standard circle equation. So this is what we were learning yesterday. That if I have, what is the standard circle equation? It says x minus h squared plus y minus k squared equals to r squared. This is what we
does
saw.
x stand as and h stand as?
So here, if you look at the circle, okay, this is the center. And this is what we have done in the class yesterday. You can probably just watch the video of yesterday's class, you'll be able to kind of relate it better. But just to give a summary here, this is the circle, center of the circle, whose coordinates are h and k. And we pick up any point on the perimeter, and let's say the coordinates are x and y. So when you visualize this in the coordinate plane and convert this into a right angle triangle. So I have drawn a perpendicular from here and another perpendicular from here. So this meets here at 90 degree and this becomes a right angle triangle for us. So if you visualize this in a coordinate plane, what we are trying to find out is this is the radius. Okay, this is the radius, right? So length of this radius will be equal to, so as per the Pythagorean theorem, let's say this is A and this is B. So A square plus B square equals this R square, right? This is what the Pythagorean theorem says, right? This square plus this square equal to this square as per the Pythagorean theorem, right? In a right angle triangle. So the base square and the adjacent, the base square and the adjacent side square of this and square of this will be equal to square of this. This is as per the Pythagorean theorem. So what we have done is, we have drawn the circle here, visualized that against the coordinate plane and said, okay, this is the coordinate of, we have just assumed this is h and this is h and k and this is x and y. So we tried finding out this length. This length is squared. The square of this length plus square of this length will be equal to square of this. So if you look at this, so r squared equals a squared plus b squared. Now what is a? This length is what? This length minus this length. This length is what? We said this is the x coordinate is x coordinate of this point is x. So this length is x. This length is h. Here to here is h because this is the x coordinate. So a square is nothing but x minus h square plus this part b square is nothing but this length minus this length. This length is what? The y coordinate, which is nothing but y minus this length. This length is k because this is a y coordinate of this point. So y minus k square. So again this relates back to the same Pythagorean theorem where it says the base square plus the adjacent side square equals the hypotenuse square in a right angle triangle. So we just related that and that gave us the standard form of a circle equation. That's what we did yesterday. I just kind of summarized that one more time so that it doesn't look coming out of nowhere. Yeah. So this is my standard circle equation. Okay.
Okay, thank you, that makes sense.
Yeah. So now, so this is the desired state. For if you are dealing with any circle equation, this will be your standard form of the circle equation. Okay. So if you have a quadratic equation like this, and you have to find out what is the coordinate of the center and what is the radius, what you will do is you will convert this into this form. So that once you convert it to this form, then you know that okay, I will find out the value of h and k. This will be my coordinate of the center, and I will find out the radius after the equal to sign. That will be my radius. So here in this case, what did we do? When we looked at this, first thing was this part looks tempting. We should be able to convert this into x plus something squared or x minus something squared. This part also looks relatable. We can convert this also into something squared. Let's see. Now, if I assume so a plus b squared or a minus b whole squared is nothing but a squared minus 2ab plus b squared. Here this is my a and this is 2ab. So 2 into b into a, that is how it becomes 14x. So this is my b in this equation. So I can say x square minus 14x or 2 into 7x plus b square. This is my b, so b square is 49, 7 square. We did not have 49. We said, okay, fine, I have 49. Let's put it here. So it at least gives me, one thing in the square form. We assume that we have 49, okay? Right now we don't have. Now, so this part is done, okay? So we have already borrowed 49 from somewhere. We don't know from where, okay? We'll figure it out. Now, the next one is this guy, y square plus, so again we know that a plus b whole square is nothing but a square plus 2ab plus b square. Here what is my y square plus 8y if I look at it? Y square 8y, 8y is 2 into 4 which is 8y. So y square plus 4 into y, so next one is 4 square which is 16. Now this is in a a plus b square form, okay? So basically for this guy also we did not have 16, we borrowed from somewhere. So now these two, by taking these 4 terms, we have formed these two square form. Now we got 49 plus 16. How much is that? 49 plus 16 is 65. What we had was 63 only. So if we borrowed the 65 from 63, that means we took 2 extra, more than what we had. 2 into 7x plus 49, or let's put a short form. Now that we know that this is x minus 7 squared plus y plus 2 squared. But we had only 63, we used 65, so that we are negative by 2 equals 167.
It's plus 4, right?
Which one?
For y.
Oh, my bad. Yeah. This is 2a square plus 2ab and plus b square. So this b is 4. So we had only 63, we used 65, so we are extra by 2. So that's what becomes minus 2 here. Okay. So with that being done, now we have x minus 7 square plus y plus 4 square equals, let this guy go to other side. We don't want anything else apart from something square plus something square. So if it goes to that side, it becomes 167 plus 2, which is 169. And 169, if you remember, 10 square is 100, 11 square is 121, 12 square is 144, 13 square is 169. You don't have to remember. I mean, if you remember, wonderful. Otherwise, you can just break it down. So this became x minus 7 square plus y plus 4 square equals 13 square. Now this is, if you relate that with x minus h square plus y minus k square equals r square, you got a straight r here, r is 38. Now you will find out here value of h equals 7 and value of k is minus 4. That is how it became plus 4. So that gave you the x and y coordinate of the center. Are you able to relate, Ananya? I mean, did I explain that in a simpler way this time?
Yeah, that made sense.
Oh.
Yeah, thank you.
Hi, Dhanusri. Alright, so now let's look at, so this one again, what I mean, I can keep on framing questions and make you guys practice, but let's try learning something little more interesting, okay? Now everybody in the class remembers what is a polynomial, right? Everybody remembers what is a polynomial? Whatever we were doing was nothing but a polynomial only. polynomial, just for everybody to recall, if I have an equation, let's say 2x plus 4 equals 10, or 5x squared plus 2x equals 3y. These are called terms. Everything that is separated by a plus or any operation or by an equal to sign, those are called terms. Here in this case you have 1 term, 2 term, 3 terms. Here you have 1, 2 and 3 terms. Imagine if I am talking about an equation like this, we have 1, 2, 3, 4, 5, 6 and 7 terms. Yep. So any equation or expression, I mean again it could be an expression also. I mean we can have, let's say, 2x squared plus 7y. That's it. No equal to sign. This is called expression. Be it an equation or an expression, these are called terms. Everything that is separated by an operation or by an equal to, those are called terms. So in a equation or an expression, these, if you have more than one term, that is called polynomial. Okay. So is everybody with me so far with respect to understanding of polynomial? Okay. Now you can have a linear equation. So basically equation and polynomial is something that you can use interchangeably. Just that equation is more familiar, polynomial is not very commonly used. Only people use it only when needed. But from an understanding standpoint, be it an equation, be it a polynomial, both refers to the same thing. Just that polynomial has a wider range. Meaning when you are talking about polynomial, you are talking about equation and expression both. Wherein equation is limited to something which has an equal to sign in it. Does that make sense? So look at it, look at this tree like this, polynomial. It has two kids. One is equation, one is expression. Meaning, be it an equation or an expression, both qualify to be called polynomial. But is every polynomial an equation? Yes. Is every equation a polynomial? Yes. But is every polynomial only an equation? No. It could be an equation as well as expression. Does it go well so far? I mean, is it going well so far?
Yes, sir.
Ritika, are you with me?
Yes, sir.
Heave? Any doubt?
No, sir.
I know this is post-lunch session, that's why it's my duty to keep waking up everybody. If you tend to fall asleep, I'll probably sometimes crack jokes which are called dad jokes to wake you guys up. Okay? So Dhanusri, you are with me?
Yes, sir.
Okay, alright. So, we just looked at what is a, I found a better cleaning device. Okay, so when you talk about polynomial, any equation or expression is a polynomial by default. Because you will never have an equation like this. This will never be an equation. There will be an equal to sign and this will mean something. Even if it is 0, still there are two terms. You can have an expression which is not a polynomial. It is monomial. But when it comes to equation, it has to be polynomial always. So when I was making a statement saying that is every equation a polynomial? Answer is yes. Is every expression a polynomial? Maybe, may not be. Right? Our straight answer would be not every expression is polynomial, because you could have expressions with only one term and that is where it is not polynomial, because poly means many. Yeah? Alright, so now let's look at some interesting facts. If I say 3x plus y equals, or 3x plus 8 equals y, and 2x squared minus x equals y. First of all, tell me what is the difference between these two?
One is a linear equation, the other is a quadratic equation.
Sorry?
The first one is linear, the second one is quadratic.
Okay, first one is linear equation, second one is a quadratic equation. Or you can also say first one is a linear polynomial, second one is a quadratic polynomial. Both goes same way. Now, in this case, do you know what do we mean by zeros of a polynomial? What do we mean by zero of a polynomial? Be it a linear polynomial or be it a quadratic polynomial? Anybody? Yeah, Ritika.
So where the graph hits the x-axis.
Yes. And see, this was one of the lamest question to ask, okay? It was a very lame question. See, this is a polynomial. What it gives it me as an output as y. When I say zero of a polynomial, meaning outcome of a polynomial is 0. Y is 0. And where will it be y as 0? Where it meets the x-axis. If I say, what is the 0 of this polynomial? You will say 0 of the polynomial means, always assume that y is your output, okay? When we are talking with respect to a polynomial. I mean, that is how you can relate it. So, if this is my polynomial, a quadratic polynomial, when I say 0 of this polynomial, it simply means my output is equal to 0 or my y is equal to 0. That's how you can relate it. And where will your y be 0? Where it meets the x-axis. Every point on the x-axis, wherever it meets, that will be a 0 of the polynomial. Yep. Now let's kind of peel off the onion here a little bit. Now let's look at the linear polynomial first. So if I have this polynomial, everybody in the world knows that this is a linear polynomial or linear equation which eventually draws a straight line in a coordinate plane. Everybody with me, right? And if you don't trust me, I'll do a very boring exercise real quick. So this is x and y. If it's an equation, there is a contract between x and y which says that 3 times of x plus 8 will be y. So if I give x equals to 1 or 0, my y value will be 8. If I give x equals to 1, it will be 3 plus 8, 11. If I give x equals 2, my y value will be 6 plus 8, 14. And you can play with it as much as you want. If I say my x is minus 2, then it will be minus 6 plus 8, that will be 2. And you can go on filling the table till you want, until you enjoy doing it. Now, on a coordinate plane, 2, 4, 6, 8, 10, 12. Minus 2, minus, okay? This is, let's say, 4, 8, 12, 16. Minus 4, minus 8, minus 12, 6, minus 16. Now, when x is 0, y is 8. When x is 0, y is 8. So this is my 1 point. So like I was saying, every point on the x-axis, y value will be 0. Same way, every point on the y-axis, x value will be 0. As you can see, I mean, no rocket science here. X is 1, y is 11. So when x is 1, y is 11. It's somewhere here. When x is 2, y is 14. Somewhere here. And when you join them, this forms a straight line. So that's why it's a linear equation. Now, that is not very important. What we are trying to find out here is okay. So here, forget about this. So this is this linear equation. When you talk about linear equation, there is only 1, 0, because it can maximum cross any axis only once. If you look at this, it touched here at x-axis. There will be no possibility of it touching here or here or anywhere else. Any linear equation can touch, or a line drawn by a linear equation can touch x or y axis only once. So that's why you have only 1, 0. Are you guys with me so far? Okay. Srivatsav? Srivatsav is very quiet today. Okay.
I understand this, sir.
Yep. Anjika, are you okay with me? Are you okay with whatever we have discussed so far?
Yeah.
Okay.
What if the line was like vertical, horizontal was a line on the axis?
So if it is horizontal, what do you see in this case? If it's parallel to x-axis, what does it mean? It won't have a zero. It won't have any intersection with the x-axis. That means there will be no x. So here in this case, you are essentially talking about equation like this. There is no x component to it. So if you don't have an x component, there will be no zero value. Okay. Similarly, if you are talking about this, you will still have x component, so you will have a zero value. But here the equation will be like x equals to 5. So these are the outlier scenarios when it is parallel to x or y axis. But in a regular scenario where you have x and y, both the elements in your equation, this is when the zero value of the polynomial comes into play. Otherwise, you will just relate it based on the fact. I mean, the underlying concept remains the same. Zero value of any polynomial or linear equation means the point where it intersects the x-axis. And for it to intersect the x-axis, it has to have an x value. If you are talking about an equation like y equals to 3, there is no x value here. X is not existent.
What if it's like y equals 0? It's on the x-axis.
Y equals 0.
So
this is a scenario where you have infinite zero values, but again this is the outlier scenario. Y equals to 0, you are essentially drawing the coordinate, x-axis of the coordinate plane. It is not a line that you are wanting to talk about, because see, if you look at the coordinate plane, this x and y axis gives you a reference point. Like you use Google Maps for driving to a place. You say, okay, fine, your address is compared with, let's say, this lane here and this lane here, and this falls in here. How far from this lane and how far from this lane? If you say you are staying on Preston Road, you just need, there's no way you are describing it actually. You are coinciding with the reference frame itself. Yeah. But not this. I'm not saying it's an invalid question. It's a good thoughtful question. But what I'm saying is, every equation that we talk about is assumed to be different from these two lines, because these two are your base point. If I'm talking about child in this family, that means I'm excluding the parents. Yep. So the lines are the child in this family of the coordinate plane, excluding the parents. Okay. I don't know if that was a good analogy, but yeah, something to keep it with us. Yeah. All right. So zero value of a polynomial or linear polynomial part, everybody understood, right? Any question, doubt? Savya, Heer, Dhanushri, anybody? You guys don't believe in challenging your teacher, is it? Sometimes you need to. Any question so far? Is it clear so far? Okay. All right. So it's called silent treatment. You guys not saying, not taking the pain of unmuting yourself and saying yes or no, but using the technology to come to your support. But that's acceptable. I mean that's not a problem. Let's look at a second flavor of the polynomial, which we call as a quadratic polynomial. And I'm just making up these equations or these polynomials on the fly. So this is my polynomial. When we look at this one, we know that okay fine, this is a quadratic polynomial because the maximum power to x is 2. So this is a quadratic polynomial. We'll do the same dirty job. Put a table. Because any equation for that matter, if I have told this before to you guys or I told that in another class, any equation, if you look at, be it a linear equation, be it a quadratic equation, be it a cubic equation or whatever, it is nothing but a contract, an agreement between the variables. It says I am x, get a square of b, multiply that by 2, add 4 with that becomes Praneeth. Let's say if Praneeth, I am x and Praneeth is y, this is the agreement that we have. If I increase my value, Praneeth's value increases. If I decrease my value, Praneeth's value decreases. So that's a contract, that's a legal is a very heavy word, but yeah, it's an agreement between the two variables. That's how you'll put it. Now, so this time we'll probably use few extra points, okay? So in this equation, let's say when x equals 0, what is the value of y? 4. When x is 1, what is the value of y? It will be 4 plus 2, 6. If it's 2, it will be 4 to 8 plus 4, 12. Let's play with some negative values also. When it's minus 1, what happens? This becomes same thing, 6. It's minus 2. I'm kind of trying to repeat the same number with a different sign. So when it's minus 2, it becomes same thing, 12. It's when say minus 3, it becomes 3 squared, 9 into 2, 18 plus 4, 22. And when it's plus 3, what happens? Same thing, 22. So now if I try plotting it on a coordinate plane and see what happens, let's say this is 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, minus 5, 1, 2, 3, 4, 5. You guys must be seeing or must be thinking that no, this guy doesn't get tired. I don't get tired when I have to draw things again and again, okay? And that is the best way for dealing with math, okay? So my recommendation or request to you guys also would be, even if you do the scratch work 4, 5, 6 times, that's okay, it doesn't hurt. And in a way, it gets you much closer to math, okay? So I would prescribe, suggest, request, whatever it is, to make sure that you guys also get into the habit or learn the bad habit from me if that helps. Okay, minus 4, minus 8, minus 12, minus 16. Now 0 and 4. So 0 and 4, x is 0, y is 4. This one, okay. 1 and 6, when x is 1, it's 6 here. 2 and 12, when 2, it's 12 here. Minus 1, 6 here. Minus 2, 12 here. So when you try joining these points, this makes a parabola. And everybody in the class must be thinking that this old man is trying to waste everybody's time. That was not the plan. The plan is this. Now if you look at this, from this what did we find? It is not crossing the x-axis at all. Okay? Let's assume that I had given an equation like minus 4. Okay? Or I had put an equation differently so that it crosses the x-axis also. Okay? So in this case, what did you see? This parabola is not going to have a 0 value. It's not crossing the x-axis. if I would have shifted the parabola down to here, this would have crossed the x-axis in two places. If I would have shifted this parabola enough so that it just touches this point, it would have had 1 0 value. So what is the interpretation from whatever we have done so far is, in case of a quadratic equation, you can have up to 2 0 values, or a quadratic polynomial can have 2 0 values. Okay, this is the ideal case when you will have 2 zeros. This is a way, this could be a likely case as well when it doesn't cross the x-axis. It is plotted above this one, it has no 0 value. There could be some equation which will plot a parabola like this, then also it has 0 values. Is that understandable so far? Is everybody with me?
Yes, sir.
Okay. So any parabola that you talk about, or any quadrilateral polynomial, can have maximum 2 0 values. So now, if you relate it with whatever we have seen so far, we saw that if it's a linear polynomial, something like this, it has 1 0 value. If I have something like this, which is a quadratic polynomial, it can have up to 2 0 values. Power 1, 1 0 value, power 2, 2 0 values, or up to 2 0 values. Similarly, if you to look at a cubic equation like this, you can just extrapolate this, and you will actually, you can see that. I mean, I'm getting lazy. I'm not plotting that on a graph, but you will see that if you have a polynomial with degree 3 or a cubic polynomial, it can cross the x-axis up to 3 times. Yes, Dave.
So I have to go somewhere right now. Is it okay if I can leave early?
Sure, no problem. I mean, you just will have an extra task of watching the video just to catch up.
Yeah.
Okay.
Okay. Thank you,
So
sir.
there is
Have a
an
good one.
interesting concept that is coming up after you leave. Okay. Alright.
Okay.
So here, when you look at a cubic polynomial, you will see that it can touch the x-axis or cross the x-axis up to 3 places. Up to 3 places. That is the maximum. It cannot go 4. It's up to 3. So it relates to the degree. Whatever is the degree of your polynomial, or the highest degree of the polynomial, that is the number of 0 values it can have. Is it making sense so far? Neil, Sarah?
Yes, sir.
Okay. And I'm randomly calling out names, okay? I'm not trying to put anybody on the spot. Alright, so Sammy has joined 5 minutes early. So beta, you'll have to join after 5 minutes, or you bear with me to learn about polynomials, which will be overwhelming for you. Okay? So this is, we just built an understanding that, okay, if I'm talking about polynomial, depending on the degree of the polynomial, it will have, or it could have that many zero values, or that many points where it will intersect the x-axis. Now, let's quickly try solving something. So, x squared minus 4 equals what? Okay? This is a quadratic polynomial. Now, here, what is the 0 value? How do you find the 0 value? X squared minus 4 equals 0. That is how the 0 value you will find. So, this will help you solve x minus 2 into x plus 2. This is what it will become. So, you got two answers, x equals 2 and x equals to minus 2. Yeah? So, these are two 0 values, meaning these are the two places where this parabola will cross the x-axis. I'm not interested in talking about this. My intention is something else. So if I look at this, these are my two 0 values. I will call the 0 values as alpha and beta. So if I have a quadratic equation, okay, any standard form of a quadratic equation is what? Ax squared plus bx plus c, correct? So This is my quadratic equation, this part which I was trying to solve. And what is the value of A? Is in this case is 1. What is the value of B? There is no B because there is no X. So B is equal to 0. And what is the value of C? Minus 4. From this one, what did we see? That if I look at, let's say that we did not have solved this one, okay? Now we have solved it, but let's say, okay, fine. If I do alpha plus beta, if these were my two zero values for this equation, that would have been what? 0? It will be equal to minus b by a. And alpha into beta equals c by a. Related to this equation, okay? So now you have got the answers, okay? So this is alpha, this is beta. Alpha plus beta is equals minus b by a. You know that your b is 0, by a is 1. 0 by 1 is 0. Look at this, alpha plus beta, when you add these two becomes 0. So this theory proves. Alpha into beta is what? Minus 4. What is the value of your C here? C by A, minus 4 by 1. So, before I let you guys go, because younger ones are about to join, what you see is if you have a quadratic polynomial and you assume alpha and beta to be two of the zero values, meaning where it is meeting the x-axis. This is the relationship that will come out to be handy for you guys to refer to. Meaning, if you have a quadratic, so basically you don't really have to solve always this way. If you happen to remember this, you can very well solve, let's say you have x square plus 4x minus 8 equals y. If you have to find it out, okay, you will say alpha plus beta equals minus b by a, and alpha into beta equals c by a. What is my b? 4. So this is minus 4 by a is 1 equals alpha plus beta, or alpha plus beta equal to minus 4, and alpha into beta equals c by a. What is c? Minus 8. So alpha plus beta equal to 4 and alpha into beta is 8. You will put, let's say, okay, alpha equal to minus 8 by beta, and put this value here. Minus 4 equals minus 8 by beta plus beta. So from this also you can solve. I don't know whether this will be more complicated than solving this equation, so I will leave it to you guys. But what I'm saying is you have an alternate that you can use for relating it, and any quadratic polynomial that you deal with, this relationship also holds true. Did I reach you guys or did I complicate? Were you able to relate what I was saying, or it was sounding more complicated than it was supposed to be? It was okay? Alright, so all the kids from level 1, just hold it for 2 more minutes. I'm just wrapping up the class for the senior kids. Yeah. Alright, so question to Neil, Sarah, Shravya, Ritika, Dev, Dev is left, Dhanushri, Pranit, Chris, everybody. Was it easy to understand or it was looking very complicated? Here, it was okay?
It was he.
Okay.
Was he?
Alright, so I will let you guys go. Have a good rest of the evening and we'll meet again. And in the meantime, between now and the next class, I would suggest you guys just do some unit test in Khan Academy so that you stay in touch with what we have learned. Are you able to practice it? Are you able to solve problems relating to what we have learned today? Okay? But otherwise, have a good rest of the evening and the weekend, and see you guys on next Saturday.
Thank you.
Alright,
Thank you.
bye
Thank
bye.
you, sir.
Bye bye. Bye bye. Take
Bye,
care.
sir.
Bye bye.